I'm back out on site. I'm just looking at a really interesting project. This is a lovely piece of work here, big steel portal frame and a lovely roof structure going around it. And I'm just out here with the guys. We're talking roof rafters, we're talking roofing squares, and we're just going to do a little bit of setting out and leave the guys with a few tips and tricks to make sure they can produce this roof, which I'm sure they can. They know what they're doing, and it's going to be quite exciting. So off to the van, get a few tools, get my roofing square out. This is also a place where I'm going to be testing some of the functions of my new roofing square. So keep tuned and see how we get on. So let's get up there, cut a few components and give them a little bit of a lesson in traditional roof construction using the metric square and basic tools. So before I set anything out, if I'm sort of doing a lot of this sort of stuff, I turn up on a job, the roof's in, or the steel portal frame in this case is in, and what I like to do is just run a geometric laser or a level over them. I've got an inclinometer here, and just check where they're running, and they should be 45, and this is exactly 45. In fact, everyone I've checked so far is exactly 45. It's really a nice testimony to whoever set it out and whoever made it and whoever installed it has got a nice job. So that makes the job of a carpenter a little bit more straightforward, because you pretty much know that this is what you're working to. Indeed, I have seen chippies lay the timber up here, clamp it on and start marking the positions on it in situ, full size. And sometimes that's another good tip. You can spend ages working this out geometrically, but you can't beat if you put a timber on here and you clamped him on and you use a level and you plumbed up the back of that bird's mouth there and the bird's mouth at the top. You're going to have an exact fit, because when you cut it, it's going to drop straight over where you need it. So you can save yourselves a lot of time sometimes instead of working something out geometrically, especially when you're fitting something that's already here. So the first job for anybody is taking a few measurements. Now I'm just going to set out a small rafter. What we got here is we've got a 45-degree rafter, small flat roof, 45-degree rafter, meeting the front slope with a hip. So we're going to set out this small rafter here just to give them an idea of what it could look like and how straightforward that is. And we're also going to be marking up a hip, the plumb cuts, the seat cuts, the bird's mouths and that sort of stuff, to give the guys an idea of what that looks like too and how straightforward that is. So I'm going to take a measurement. The first measurement I need for this rafter is effectively the distance between here and here. So if you can imagine, if they were on the same plane, I'd be measuring across. And that is what I call my span or my run. So we're going to just do that with a level. We're going to plumb down and measure across. And we'll do a little sketch. And we know from there to there, which is our critical measurement, 535. We'll just give that a check at the other end. So we've got a little tiny bit of difference, not a great deal, nothing to really write home about. And basically we've still got a little bit of movement here, so if we wanted to, we could cut it and get it exactly right, because these, until they're braced, will always have a little bit of movement in them, as you can see. All I need now is the height difference between these members, which is the same difference. I'll just stick my level out here and I'll measure down. And we got that now. Right, and all I know is that we want our bird's mouth or our rafter foot to hit the bottom of this member here, so that's what we'll call our setting out point there. I'll just check what that is. It's 152. Let's make a little note of that. Right, we'll go and cut this and see what that looks like. So anyone who's interested in my square, this is the square. I'm out on site doing a bit of testing with it, and we're just going to be setting some rafters out. So I'm just going to run through the basics of the metric roofing square. I have a fence, as you know. This is something I made years ago, and now I know a lot of guys use it as well. It's just very simple. This is a prototype fence, so the new ones will be smaller. So I'm working on a pitch at 45 degrees. So on the square, you see pitch is 0 to 66. That is effectively the top of the rafter. I'll bring this end round to 45 on here. And now we're set up ready to go, and that's the same for every pitch. We always strike from this point. It's like a protractor, it's like the center of a protractor. We strike from here, and away we go. So we're gonna get ourselves a scrap of timber, something which is gonna be long enough to do the job, which is gonna be about 2 meters. We'll get a couple of meters of 175 by 50. So that's a bit bigger. That looks like it's a ridge or a hip or something like that. Let's have a little look. Right, have we got anything? Oh, a couple of meters long. Is this your practice pile, guys?
This is low when we've dismantled our model.
Oh, blimey, it was a proper model there.
Yeah, we did a model up there.
I mean, when you said a model, I thought you meant a model, not a model. Well, it's good though. Sometimes you need to do that. I built my whole house as a model. That one, I reckon these are hips, but they're 7x2s anyway, aren't they? So we can pull him out.
We'll just cut a new one.
No. We can. This one here will be absolutely. This one will probably do the trick. Oh look, you've got more birds' mouths on that. Look at that, that's a right fine collection. That's a fine collection of birds' mouths there, all going different ways. There we go, this is probably good. We'll try this one. This looks about right. Okay, so the very first part of the job, I know I'm sitting over that steel at the top and I know the height of that. This is a tiny rafter, so we can use what we call stepping off. So the first job will be moving all this. We've got more squares on this job than I've ever seen. It's like a tool shop. Right, so the first thing we're going to do is step it off. So we're going to start with a plumb cut at the top, and we know we want to sit on 152. So let me just see, give ourselves a bit to work with. So it's a bit alien, but we want to work to the bottom of where we want the rafter to finish. So we know it's 152, the height of that timber to the top of the steel. There. And if you would put in a timber on the top, it would sit there effectively on the back of that steel. So that's effectively the cut at the top. We now know the height from that steel up there that we showed to the next steel. We know what that is. That was 642. So we'll step that off. Stepping off is using the scale here to measure it. So we go 300 and 342. So that's effectively the steel below, and that's the steel above, and that's running at 45 degrees. Now what we know is we know where the back of that one is, and we know where the back of this one is based on that measurement where we measured plumb down and measured across, and we know that's 535. So we want to step that back 535 now, which is easy enough. We use the scale on the bottom of the square now. So we go 300. Someone stole my daylight. And 535. So we're going to go 1, 2, 3, 5. There. Sits on the steel, maybe intended by the engineer, who knows. So that's effectively the bottom, and that would be the top, keeping it where we want to keep it. Are you with me? Are you sure?
Signature trademark.
Now do the bottom. We can just, and whether the heel fully supported, don't you? Which is the nicest job really. So this is template 1.
So would use
395. That's the bottom of the rafter there. Now what you want to see is 2/3 generally, right? So 2/3 of this, let's just cut that there, 70, 140 is there. 2/3 of this is here, which would be a typical bird's mouth, all right? So that's 2/3 of the timber and 1/3 of the timber. Now what we're looking at upstairs, from the back of the rafter, at the minute is here. It's there, yeah? The wall plate that you got up there at the minute is here, yeah? So that's where, if you relate this to the steel that we just looked at, yeah? That's basically the line I put on the steel, which lines up with that bottom corner of that timber. And then this is the relationship leveled back to meet the corner of the wall plate, that you've got up there. There's a bit of that sticking around somewhere. Look, here we go. That's there. Yeah? That would give you a bit, and if you think how long the foot is past, it would give you a little bit of a problem, potentially. Yeah, that's your 400 drop. So really you want to be more like there, which pushes the roof up higher. Yeah? Which means then you'd be sitting over the steel effectively. So that would become the top of the steel, and that's what you'd have over the top at the point of intersection, yeah? And you wouldn't make that timber.
So that would be the top of it. So this is what would be hanging.
Yeah, and you wouldn't make your 5x2 at the minute is here, about 10 mil down. Yeah, so you'd be traveling, instead of being there where you wanted to be because of the wall, you'll be there, and that's the top of the steel. Yeah, so that would be, I mean you can cut this to any height, you know, but you're not like that what you want it to be.
Ideally that's how anyone would probably want it, right? So
I think you want to make contact with, like you say, with that, so you've got decent fixing and the heel of the rafters supported.
So if you want to go like that, then that wall plate needs to drop.
Yeah, or you've got to have a rethink and bird's mouth everything over the top of the steel onto a ridge with a ridge behind it, but only restrict the height of it so your build-up's not affected. Well, let's just work that out. So if we did go on the wall plate that's there at the minute, the difference is between there and here, how much it will be pushing it above. It's 120. All right, so where we are at the moment with that other template that I did, which was 152, it will be 152 to the bottom. Let me just mark another cut up here. Here we go. At the moment, the steel is there, and that's where you are at the bottom of your timber. It's the same as what we did on the side. And if we have to shift it up to sit it where we want it to be, which is here on that one effectively, not over there on that one, the difference between that is 120 there. This relationship to the wall plate here would have been the same as that. So meaning the height of this portal frame might have wanted to be down to that point, yeah? Yes. Which would have given you this reduced height, yeah? So the whole thing might have wanted to come down, which would have pulled this one down, which might have impeded your headroom a little bit.
Part of my work is consultancy, where I visit sites and talk to people. It may be tradespeople, it may be developers, site agents, to actually overcome issues, because it's quite easy for an architect to produce a drawing or drawings, an engineer then takes it on, puts loads of heavy steelwork in it, but actually for guys on the ground who are building the projects, it's quite nice to actually have a little bit of knowledge to be shared and get the job done.
Down we go. So I'm going to make a mock-up of a hip, so a hip foot, a hip top, and see the relationship to one of the jacks and how the relationship is to the hip where it should fit. So we know we've done the template rafter foot for the main build. We'll put a template on the bottom of here as well for the hip. So I'll just get my square. Now on the square we have got hip valley run up to 66 degrees, so we can just use this little arrow here, and then we bring our fence round to 45, which in this case is the pitch of the roof. So we're hip and valley and we're 45. That gives us the correct angles for everything we need for a hip or a valley indeed. So we'll tighten them off. Check everything, make sure we're happy. Hip or valley, 45. Let's mark a seat cut first. We got a 400mm drop currently. So we'll step that off. That would be a 400mm drop. Now, what we need to do is make sure the bird's mouth is exactly the same height from the pitch line as the rafter. So on the rafter, we're using a 7x2 and we're using it at 2/3, which is technically what we should always be, 2/3. And so we'll just mark that on here and I'll give you a measurement. So this is 2/3 effectively of the plumb cut. Let's mark it down there. That gives me a measurement plumb of 157mm. Now that's also what I need on the hip, 157mm plumb. Here we go. So that is the bird's mouth there. So this distance, 157, measured plumb. Plumb is upright, everybody. There, that's the edge of the plate, the corner of the plate. That distance would always be the same as the margin on a common rafter plumb as well. This is running at 45 degrees, that's a rafter. Obviously a hip runs at a lesser degree. So that's effectively the same foot, because it's doing a longer distance, it travels at a lesser pitch. So now we're going to cut the top, plumb cut. Well, we don't need to actually cut, we will cut it, but we'll mark it. Someone's had a go at this already, so you can see they're not far out. That's it there. Now, if we were going to put a rafter against that, a 7x2, you can see that it actually fits perfectly. Can you see? Yep. The height there. 200 by 50, 175 by 50. And it works really nicely, yeah? Especially for if you were boarding, battening, and you wanted to meet it all here.
It's on the 8x2, yeah?
Yeah, all right. That works nicely, yeah?
It does, yeah.
So, let's cut that off anyway.
Yeah, look.
good thing about lithium, it just goes. It doesn't say I'm getting ready to go. It just goes, doesn't it? It just says, that's me, I've had enough. Cheers, mate. So that's effectively a hip, right? Yeah? Plumb cut, seat cut, at the height of the bird's mouths that we're working with up there.
Oh, the jack. So this.
Yeah, so when you've got a jack rafter at 45, so it makes it look a little bit more like a hip. That's effectively where you need to be, with the bird's mouth the same as the one I showed you.
Yep.
And this is the correct bird's mouth to fit and make everything. Yeah. I've had an interesting morning, been out on site, a couple of really nice guys, and we've been looking at roofing and all the rest of it. It's a little bit like research and testing for my Square and my app. And I've just left the guys with a couple of small models of different parts of their roof. So we've got a little tiny section here which represents a steel that the roof timbers will sit over, another steel that they'll sit on, and so on and so forth. We've also got a little template of a hip. This is universal. It might be a left hip or it might be a right hip, and how the relationship that is to those two small steels. And so it's a little bit like testing, showing, talking and sharing knowledge, and I think that's what we're all about. And anyway, thanks so much for joining me. Catch you all again soon. Check out my roofing videos coming up shortly. I'm sure you'll enjoy them.